Now we'll consider special series, so-called geometric series. So geometric series. Geometric series in general look like a plus ar plus ar squared plus ar cubed plus and so on. So what is happening is every time to get the next term, we keep multiplying by the same number. In this case, we multiply by r. In general, we can write it as ar to n and from 0 to infinity. So what we want to do is we want to investigate whenever and when the geometric series is convergent or divergent, and if it converges to what. So let's write down the nth partial sum. It's going to be a plus ar plus ar to n. Now if you multiply it by nth partial sum by r, we're going to get ar plus ar squared plus ar to n plus 1. And what you notice here is we can rewrite it as, I will squeeze an extra a here and rewrite the rest. And the term before a times r n to n plus 1 is a to r n plus a to r n plus 1. And because I put extra a here, I have to put an extra a on the left side. I put an extra a, I put an extra a to balance them out. Now if you look at what is written here, that is Sn one more time, because Sn is a plus ar plus, so it's n partial sum. So what you've got is a plus, oops, so that expression in the rectangle is Sn and partial sum. So what we've got is the following. We can solve it now for Sn. Say subtract Sn from both sides, subtract a from both sides. So we're going to get r Sn minus Sn equals to a. So what we've got so far is r times Sn equals to Sn plus a times Rn plus 1 minus a. Subtract Sn from both sides. What we've got so far is a plus Rsn equals to Sn plus Irn plus 1. We solve it for nth partial sum. So r Sn minus Sn equals I times Rn plus 1 minus a. Solve it for Sn, so we get Sn equals a to Rn plus 1 minus a over r minus 1. Now to find what the infinite series equals to, we take limit of that partial sum as n approaching infinity. We don't have problems with taking limit of a. We don't have problems with taking limit of r minus 1. So the only thing which we are concerned about, how to take limit of r to n plus 1. And in order for that limit to exist, r has to be small. Absolute value of r has to be less than 1. So we conclude that if r is small, then this expression r to infinity is going to be 0, so we were going to get s going to be equal to negative a over r minus 1, and often we'll distribute minus multiply top and bottom by -1, so we're going to get a over 1 minus r. So to summarize, I will write down the following geometric series test. So geometric series test. A plus AR plus AR squared plus and so on equals. So geometric series is going to be convergent to A over 1 minus R when absolute value of R less than 1. That's the first case. And if R is big, if absolute value of R is bigger than 1, their corresponding series is going to be divergent. Divergent when absolute value of R is bigger than 1. So let me run example on 2 how to illustrate the divergent geometric series test. If we look at the series 1 plus 1/2 plus 1/4 plus 1 over 8, we realize that is geometric series. We also realize that A, which is the first term, is initial term is 1, and you realize that to get the next term we always keep on multiplying by 1/2, so R equals to 1/2. So absolute value of R, which is equals to 1/2, is less than 1, therefore it's convergent by geometric series test. And converges to geometric series test tells us it converges to A over 1 minus R, so 1 over 1 minus 1/2, so finalize this term. So this series is going to be convergent to 2. Let's run another example. Here we have infinite series, which is given to us in a sigma notation 3 to n over 4 times 2 to n, and from 1 to infinity. And we want to determine when elevate series converges to diverges. Converges to what? What we'll do is we want to write down few terms to realize what kind of series we're talking about. When n equals to 1, to get 3 times over 4 times 2 plus next one is going to be 3 squared over 4 times 2 squared plus 3 cubed over 4 times 2 cubed. And if you look now in that expanded notation, it's kind of obvious that it's geometric series, but the first initial term is 3 over 4 times 2. And you realize that to get R, we keep multiplying numerator by 3 squared, 3 cubed, and we multiply by denominator by extra 2. So R equals to 3/2, so geometric series. With R equals to 3/2, so absolute value equals to 3/2, it's bigger than 1, so therefore it is divergent by geometric series test.